Okay, thank you so much. Yeah, first of all, a warm welcome to the fantastic audience here in the room, but also to the audience around the world, connected online. Hello, world. Well, my name is Steffen Loest, and it's a great pleasure for me to give you some insights in the next 20 minutes in our DAAD-funded project BooST. BooST is the abbreviation for Boosting Skills by Digitalization and Training. And now I will give you some information about what we do in BooST. Well, as I got the call for paper, I found very interesting questions. Here red highlighted, so sorry you cannot read exactly. How can teaching and learning be linked via digital formats, tools and forms, but also truly innovative teaching learning scenarios be designed and implemented sustainability? And the last question, it's not highlighted, a role to education, or what role do education platforms play? And the fantastic point is, BooST is dealing exactly this question. Yeah, and the problem is, BooST is still not finished, so I cannot present our final results, our final findings, but maybe in 2 or 3 years I can come back and then you will get more insights about how to do this one. He told already I'm from the engineering faculty, and the engineering degree courses are characterized by a special point because they are very huge part of practical laboratories and experiments have been implemented in those courses. Why do we that? We try to transporting theoretical knowledge into practical skills. Well, take the example for small children. You tell them biking is quite easy. Keep on pedaling, keep the handlebar safe, and keep the balance. That is the theoretical knowledge. But can the child using a bike? No. He needs to turn and to train the practical skills. That is what we do in a laboratory experiment. The second point, deepening of knowledge and foster ability to act. Deepening of knowledge means we have several stages to gain new knowledge. We can listen new knowledge, we can watch new knowledge, we can listen and watch, and we can do it by ourselves. And each step has the effect that the gained knowledge gets more in with increasing the steps. And foster ability to act. That is a very important point. So our alumni will become operators, chip operators. They have the job to maintain and to operate a huge, complex chip engine system. Everything is fine as the engine is running. But in a moment where the engine is disturbed, the process is disturbed, he has to act. First of all, he has to act for an assessment. He has to assess what is disturbed. Second, stop the disturbance. And third, bring the engine back in a normal operation. And this line will be trained in our laboratory experiments. Team spirit as well. Chip systems, but not limited to that, also in onshore systems, having the fact they are really, really huge. We are talking about several rooms, we are talking about several meters high and several meters long, and so on and so on. Nobody is able to solve problems in those cases by themselves. You need a team. You need a team, the team must work. You need the communication inside a team, yeah? You need a communication on the horizontal level, but you need also communication in the vertical level to a management level, maybe for the company or something else. Or in our cases, mostly it is the laboratory engineer. But you need to train the communication and the interactivity within a team. Leadership skills. Each laboratory attempt has a chief engineer. So one student has the power of the order. Yeah? There is the chief engineer, and he has to explain what is to do, and he is ordering all the processes inside the experiment. And these are the points what we try to train during our experiments. And it is really hard to transport these 3 points into a digital world. Yeah. Well, it might be very interesting for you to get some information about our motivations, why we do BooST. 12 years ago, with the kindly support of the DAAD, we started our international degree program, Marine Engineering, in Indonesia. Marine Engineering is a special course. It is designed in 2 major parts. The first part is the ship building part that is related to our partners in Indonesia at the ITS. And the second major topic is ship operation. So we share the teaching content to equal parts. It means we have more or less 3 semesters. 3 semesters to explain to students how ship operation is working. Yeah? And while in the past we decided to bring at least the laboratory experiments completely in our responsibility. So we sent 1 cohort once in the 5th semester to our university. And while the time they get a compressed teaching in laboratory experiments. Yeah? And now we're talking about the experiments of 3 semesters will be compressed in 1. So we have to deal the time. And the problem of that is not only the number of experiments, the problem is also the limited factor of members inside 1 experiment. So we're talking about 8 students have to take part in 1 experiment. In the best case, 15, in the worst case, 4. So if we have 40 students in 1 cohort, we have to retake 1 experiment 10 times. So, and if we're talking about absolutely about 20 experiments, so we will have to produce a lot of work. That is once ordered for the organizational problem, that is a problem for the staffs what we have, that is a problem for the experiments, what is available in ours. That's why we try to select what of the laboratories can be digitalized and outsourced 1 semester before or 1 semester after. Yeah? So that is time related. So we have to work effective and efficiency. And by simultaneous maintaining the high quality and the quantity. The second point, why we do the digitalization is overcome the time difference and distance. Well, I was talking to you, our partner is Indonesia. So we're talking about more or less 8,000 miles distance between Wismar and Surabaya. So it's not so easy to jump very quickly to Indonesia. And the second point is the time. So we have 6 hours delay now. Now it's 12 o'clock in Indonesia, we have 6 o'clock. The day is off. It's not sensible to start now with a very important lesson or something else. Yeah? And the second point is by digitalization of our laboratories, but also other lesson parts, we put this one in our platform, StudIP, and there is it available 24/7, 365 for everyone. So the student can download or can get in this access and see all the information which is necessary. The last point is save valuable knowledge and stay up to date. Well, we are currently hardly affected by the problem that a lot of our professors has to go in a pension, they switch, yeah, and new ones will be filled the gaps. But we lost a lot of knowledge by this change, yeah, and digitalization is able to save this one. Also the problem that a lot of our scientific workers can only hired for maximum 6 years. After that they have to rechange by a new one or replaced by a new one. The next point, serving expectation of youngsters. That was a really interesting point. 10 years ago, I have been visit the first project manager meetings from the DAAD, and one professor of the RWTH Aachen give us a presentation and explain to us what he do. And he told he is going away from blackboards and presentation and something else. He is more switching to gaming and videos. So it met more the expectation of the youngsters, at least male, so male, not female, but boys is very important. And the result, what he found, was very, very interesting. So the learning outcome was increasing by gaming and video tools using this one. Yeah? So it means turn old methods in fresh idea. That is the point. Oops. Yeah, and what is now the part of BooST? We split it in 3 headlines. The first point is the digitalization itself. So we try to digitalize some laboratories, but also the lesson content, the lectures, the seminars, the exercises, and bring it in StudIP. Yeah. The second point, that is what I go later on deeper in. The second point is the platform. The platform is answering the question at the beginning, a very important part. So it connects all stakeholders with one click. So students have an access, the professor has an access. So we can provide our study materials in StudIP, and the students have all the time access to that. And we can, nobody lost or something else, yeah? So we use this one to distribute our knowledge, our materials, but also for applying our digitalized laboratories. And finally, we get the opportunity for check the learning outcome. So there is a short quiz in, and also a blabber function, or the chance for a chat room, and so on and so on. So StudIP, and I guess it is a very, very important part in distance learning, in our international cooperation, to maintain the contact to our students. And finally, the human resources. We want to create a portal for our international students, for the alumni, with the aim of capacity building. So we have the professionals, the industry and the companies have the job offers, yeah? So we want to make a connection of that. For example, German relations, one of the most important issues for the DAAD, will also be implemented in BooST. So we try to transport our cultures and our nature, that others can better understand where we are and why we do some things, yeah? And finally, long life learning. So we are developing courses and programs for later on, which are used to make some refreshing of knowledge, or earning new knowledge, and so on. Long life learning. These are the 3 main points in BooST. If we are talking about digitalization, we concentrate on 3 tools. The first one is the video one. I love this one because it is very fast. So you have to create a video manual, you have to make some records, and you have to follow up the records and present the video. So let's talking about 1 week. So, and you have a full video available. So applicable for processes which are hard to simulate. And very, very interesting is the point that the student really get a direct impression about the complex system what we are talking, yeah? So it's not really easy to take the theoretical knowledge from the paper and put it in an existing plant. So there is a huge difference of both. Using video materials, you can explain very, very easy, very fast, and the audience can watch what do you really mean. And the audience have also a picture of the lecturer, so it gives the option to personalize such a video, yeah? Tutorials is also a very important part, but I will not spend so much time for tutorials. Everybody should know what is a tutorial, so we recording this one, rendering in YouTube or MP4 format, and put it in StudIP for access for everybody. And finally, that is what the most expect, I guess, because digitalization, that is the simulation and computing of existing processes, yeah? So for that, we're using actually LabVIEW and MATLAB. That is not a gimmick to make advertising for these companies. That belongs to our standardization. Everybody of our scientific workers are able to work with LabVIEW or MATLAB. And I was telling you about the fluctuation, yeah? And if one of the scientific workers has to leave and the new one is coming in, he can work with MATLAB, he is able to care the program, to improve the program, and so on and so on. That's why that is our standard, yeah? And finally, our chip simulator, chip engine simulator, I will show you some insights about this one. Now we're talking about the next point of digitalization. What you see in the upper picture is a 6-line or 6-cylinder inline engine. That is a normal diesel engine with 1 megawatt output, so 1,300 horsepower. That's a smaller one. You can find it as a prime mover for smaller coastal vessels, but also for auxiliary engine on board a ship. But around this engine, we can implement a lot of experiments, yeah? One of the ideas is the commissioning process of this engine. It's not like a car. You can turn the key and the engine is running. No, it requires a lot of processes before. So a well-trained worker needs at minimum 1 hour to start this engine. He has to prepare the fuel oil system, the lube oil system, the air system, the water system, and the electrical system. They need 1 hour before he can start on the button and the engine is running. And you see there's a very complex system behind the engine, and it is very hard to simulate this one. But this option is already also available from the engine manufacturers, for example. Yeah? So we do not want to reinvent the program again. But what we do now is in the picture below. You see there in a screenshot from all the information what the chip engine operator has in his engine control room. Yeah? Here, on this picture, he gets an information about what are the parameters of my engine. And that is all what he needs. And now I can take this software and put it in a classroom. Inside the engine room, I'm limited to 8 students, maximum. In a classroom, I can put 20 students. So I can double or third time my capacity, yeah? And so I save a lot of time. The next point is I can take the software and bring it to Indonesia and can put it there itself. I only need an access to our campus intranet. That is everything. And then the engine is running in a laboratory, and the students can sitting in the classroom and getting the same information. So what do they with the information? One of the most important part is to make an assessment about this engine behavior, energy balance, and so on and so on. And the best thing in this software solution is we are now able to make the energy behavior or to repeat the energy balance without running the engine, because all the engine parameters have been stored in a database. I need to connect only this software with the database, and I can perform the energy balance for the students. And this is all what you really need. You need only the information about how it works and the parameters, and then they have to calculate a lot of things. Yeah? And yeah, that is the huge advantage. And finally, we was always talking about climate protection. We save at one day 1 metric tons fuel oil. Yeah? Oh, yeah. Okay, so now we are at the next picture. I will give you some insights about our chip simulator. Now we get a view on the bridge. So I guess I need to switch on. Yeah, we get a view on the bridge. All this the belongings, what you see inside the windows, belongs to the bridge. It is hardware, and below the hardware we have the software. Outside the windows, we have only 3D Max simulation. Yeah. Now we get the view to the approach of port of Stralsund. On the right side, we see the small island Denholm. On the back side, we see nothing because there's the exhaust deck from the ship. You have no options to see in the stern direction. In front of us is the Rügen Bridge, and on the left side, you see in a few seconds, for example, the yard of Stralsund, the Volkswerft, and inside this, oops, I can switch this one. And inside here, you have the most important instruments and equipment, all what you need. There is the radar, there is an active system, there's a steering system, there is a radio system, and so on and so on. And now the students can get the first information about how is the bridge constructed, how it is work, and so on and so on. And finally, I will give you some insights about our engine control room. We have the simulation of an engine control room, but also from the engine room. But the engine room will not playing a role in my videos now because the engine control room is interesting enough, I guess. What you see here is the panel. That is a replica of an original engine control room. We have the information to control the water system. We have the information about to control the loop oil system, the fuel system. We have the opportunity in the middle here to control the engine, to accelerate the speed, to decrease the speed, to accelerate the power, and so on and so on. And on the back of that, we have the switchboard, the main switchboard. Here we can switch all the diesel generators, we can switch the turbo generator. Here in the middle, we have a main switchboard for a medium voltage plant, like on a cruise liner, yeah, they're working with 5,000 volt, and it is required a special system behind it, and also excellent trained workers. Yeah, this is what we have. Below each information E, I cannot show you that because it is actually it is an interactive display, but for this presentation I cannot switch on E. If you switch on E, it is possible to get much more information about the system, how it works, how it is connected, what is the special things, and so on and so on. Yeah? Okay. I guess this is all. I'm at the end of my presentation. I hope I could give you some interesting insights about this one, and yeah, thank you for your attention. And may you have some question. I'm ready for that.